Okay, let him join. Good morning to all. So, in the last class, we were discussed about the igneous rocks, especially the second model, the petrology. We were discussing about the petrology, right? So, before that, in the first model, we discussed the importance of the earth science, geology in the field of civil engineering practice, and also the what you call this internal structures of the earth that we discussed, and the composition of the internal structures of the earth with a different layer, crust, mantle, and core. That two are the main part in the first model, and as well as we discuss about the mineralogy. It's the study of study of physical properties of minerals. There are about maybe for you guys there will be about 20 to 25 minerals are there, and those physical properties you need to read it very well for your examination point of view, and also you need to I will share the snapshot of those minerals so that you can easily understand what type of rocks, sorry, what type of minerals are there and how it occurs, and those properties also I'm going to share you in the PPT as well as in the notes also in the Google Classrooms. I think still there are 3 students who are not yet joined in the Google Classrooms. So for them it's difficult to communicate for the the PPTs and any communication related to the classes. So difficult for them. Those who are not yet joined, 3 students are not yet joined there. So immediately you joined in the Google Classrooms, right? So don't completely depend on the WhatsApp. Okay. So you should be joined with the Google Classroom with your official email ID, not with your personal email ID. Official email ID in the sense BMSIT college email ID. Okay. Then only you will get all the the things the study material and everything there, right? So in this class we are going to study about the model 2, where we stop in the, it's called yeah uh, Adarsh, can you see the slide now?
Yes,
It
sir.
is visible, right? So the petrology, study of petrology, we discussed there. What is petrology? What is what is a rock, right? And how it forms of the especially the igneous rocks and different rock types, monomineralic rock, polymineralic rocks. We also discussed there. And what is rock? Rock is an aggregate of minerals. That means more than one mineral, if it contains, that's a polymineralic. If it is a only one mineral, that's called a monomineralic rocks, right? That we discussed in the last class. So here is the granite, quartz, orthoclase, plagioclase. These are the polymineralic rocks, especially in the granite. So when it comes to the basalt, composed of plagioclase and agate. So when you take the basalt rock, it contains plagioclase as well as the agate, two minerals. Dunite, it composed of olivine. Marble, it's composed of calcite. Sandstone, composed of quartz. So these are all the monomineralic, and these are all the polymineralic. Okay, right. And this is how the rocks were forming, especially the igneous rocks, due to the cooling magma chamber. It's actually the cooling magma chamber, due to consolidation and solidification of magma. The first formed basalts and almost all the igneous rocks were formed. Igneous rocks were formed from the solidification and consolidation of the lava or the magma. That's all. That is the definition of how rocks were formed. Okay. Then the next part is that the erosion, transportation, and deposition. That's the sedimentary rock process. And metamorphic rocks, that is actually the existing of sedimentary as well as igneous rocks. Those two types of rocks undergone for physical chemical alterations due to high temperature weather condition. It has got metamorphosed, altered rock. That is called a metamorphic rocks, right? Igneous rocks are the first formed rock, and rest of the two rocks are the later one, which is through the what you call this metamorphic and what you call another one called sedimentaries. Let me show you some of uh, the the cycle of this. Can you see this? This is rock cycles. Don't get confusions here. See, when the igneous rocks, the lava eruption, magma eruption is happening here. So the voice is audible. Manoj, Manor, voice is audible. Hello, it's
Yes, sir.
audible. Okay. Uh, Let us go with the first, right? Right. So this is actually the rock cycle. Look at this. Magma eruption is happening there. First from rock is the igneous rock. From there, it is called disintegrated, get into the different pieces due to high, weathering, due to temperature and pressure on the surface of the earth. uh, so it has got disintegrated and get start erosion through the water. And if it is a very lightweight material like a sand, it may come to the it may come through what you call this air also. Okay, in desert areas generally it happens, the transportation of the sand from one place to other place, that is through the wind itself only. That is a mode of transportation. But when it comes to the land in the heavy materials, that is through the water only. Okay, igneous rocks gets disintegrated, weathering, transportation and deposition all along the lowland places on the surface of the earth. That will, we call it as an sedimentary rocks. These sediments are settled down at wherever the suitable place. That's called a sedimentary rock sediments. Okay, then finally it may be consolidated or compaction, or it may be a cementation all with the clay minerals like a mud type of minerals. Okay, soil, clay type of iron or calcareous, any type of material, it is consolidated and compacted. These, the pebbles or gravels together, compacted and cemented together. That's called sedimentary rock deposition. And when it comes to the metamorphic rocks, see here, sedimentary rocks gets metamorphosed because these two are existing rock now. Igneous rocks are formed, then sediment rocks are formed, right? Then these two rocks on the earth surface, it undergone for changes due to climate, due to heavy cold, due to a lot of heat, and then there will be heavy rain. Start getting the metamorphose, changed in the rocks, surface of the rocks, physically as well as the chemically, right? That we call it as a metamorphic rocks. This is a rock cycle, what we call it is. This is a continuous process happening on the surface of the earth. But it may take 10 years, it may take 1 year, or it may take million years. It depends on the, where it is occurring, how it is occurring, what are the conditions, it encountered in the particular place. Depends on that. Right. This is a continuous process till it's going on. Okay. Whatever we see just now in the current scenario, it happened already in maybe 100 years back, or maybe 200, or maybe 500 years back. Right. So still it is under process, still it is going on. It is a continuous process. Okay. And let me show you some of the what you call this history of what you call this uh, chronostratigraphic, what you call this, the chart, which you can easily understand what was the 4,500, million years back. That means 4.5 billion years back. Look at this chart. This is actually in the Phanerozoic or Precambrian chronostratigraphic chronological order. This is made in the 2016, but here in previous also they made it, and but here is a modified this one. Okay, so what we in the 4.5 billion years back, what was there? Hidden, nothing was there. It's just an informal. Can you see the slide now? It's visible. Hello.
Yes, sir. It's visible.
It's visible, no? Okay, you can see this. Nothing was there in that time. That's called, we call it as an Archean period. Archean period. That is in 4.5 billion years back. Nothing was there. Okay, these are the years that we call it as an era. Okay, call it as in eras and years. Here you can see this eon, era, and period in subdivided, and it's an million years back. Okay, and here you can see this. This is starting. Nothing was there. This is complete the Archean period. That's called a Eoarchean, Paleo, Meso, Neo-Archeans. Okay, so this is all comes under Precambrian period. In that Archean, there will be Neo-Archean, Meso, Paleo, and all those things were there. And here nothing is here in the period. And Paleo-Proterozoic, Meso-Proterozoic, all these subdivisions were there. Okay, right. Then when it comes to the little bit again for what is this? 541 years. That's called a Cambrian. That's called a that's a major one is a Precambrian, then Phanerozoic. In that there is a Paleozoic, and in that again there is a subdivision called different. Cambrian is there, Ordovicians, and there is a series are there, and subdivisions are there, and there will be a series of ages. Where is the life starts here? That we need to check it now. So we need to check the lights. Here is a Silurian, Devonian period, and Carboniferous period. Okay, and where we got the Permian. Okay, and it's all a stratigraphy. We call this a stratigraphy. Okay, this is a Triassic period in the Mesozoic. This is a Triassic period. When it comes to the Jurassic only, you will come to know that yes, there is a Jurassic period was happening there. See here, it's a Triassic upwards. Then there will be a called Jurassic. So where there is little bit the plants and animals happening there, right? Apartheid in that. Then when it comes to the Eocene, Paleocene, and Cenozoic, then there will be a start with the Aquitanians, the mammals, okay, some plants, Pliocene, okay, right. Then it comes to the last part of the Holocene. This is a quaternary. It's called it's an recent one, okay. And when it comes to the complete chronological order, that is what we have this now, okay. And this is generally just why I showed you this because you need to understand what was in the 4,500 years back, what is now there. Okay, the life is started somewhere here in this Mesozoic. In a Jurassic, it's only start the plants and animals, all those things started here. Okay, then now we are in the topmost layer. So this is the division dates and various eons, eras, periods, and epochs and ages are based on the range of events and the different types of events. Okay, and still it is is processing. The first appearance species in this applies to the life of forms, plants and animals. Bacteria only were there. Okay, and because of for example, first oxygen breathing organisms, first speed of producing the plants, and so on. So all these things are in the very olden days. It is happened there. So let's go back to our the classification. So far we discussed about the physical properties of rocks. So what are the physical properties of rocks? The color, textures, grain sizes, mineral composition, cementing material, and specific gravity, and the acid reaction and magnetism, all those things. So here is the description we discussed in the last class. So now here is the classification of igneous rocks. So we have seen the igneous rocks, how it looks, what are the different colors and different types. Okay, so here classification is based on the silica percentage in the igneous rocks. Silica percentage in the igneous rocks. So some igneous rocks are more than 66%, and some more rocks are 66 to 55%. That we call it as an intermediate. First one is a acid igneous rocks, and so third one is the 55 to 40% of silica percentage in the particular rock. That's especially in igneous rocks. That's called a basic rock, and it's a less than 40%. That's ultra basic rocks. So this is based on the silica percent. Again, another one is based on the mode of occurrence, how it occurs. So in the plutonic rocks, hyperbasal rock, and volcanic rocks. So this we discussed in the last class, right? In the classification of rocks, we discussed the plutonic, hyperbasal, and plutonic rocks are there. Plutonic rocks are those rocks which are formed beneath the surface of the earth. In the deeper level, it was forming. So those rocks and hyperbasal rocks, those are shallow depth. That means below the earth. The volcanic rocks are formed above the earth surface, right? Those, that is a clear cut concept. So now, so here the plutonic rocks, what are the rocks are there? Grey granite is there, pink granite, grey granite, cyanite, diorite, dunite. These are all what we have seen, especially generally in the market. You seen the only the granite. It may be different color of granite. So and also this we call it as a plutonic rocks, plutonic igneous rocks. Next one is the hyperbasal igneous rock. It's a pegmatite, granite, and also porphyrite. Okay, and also cyanite, porphyry, and the direct porphyry and dolerite. These are all the rocks names, rock name. Okay, hyperbasal rocks. So volcanic rocks, volcanic igneous rocks. These are all rocks are formed above the Earth's surface when the volcanic eruption is happening there. So this time it was happening. That's called basalt, which contains 55 to 40% of silica percentage here. Okay, andesite and trachyte, rhyolite and OBC, and pumice. And this you can see easily. And the pumice is generally we use it for lightweight concrete. That's the one thing, and it's a very the milky white color. And also I'll show you that the image, the rock photography I have. So it's a very white color, and it's it occurs in the volcanic neck, where there is a volcanic the eruption is happening there. That place you can see in this place you can see this the what you call this pumice rocks. That's a very lightweight. Huh? Okay, and yeah, that's a lightweight one. I'll show you that. But that volume wise is maybe a big, but light weight wise, it's so lightweight. Okay, right. So these are all the classification of igneous rocks. Let's go to the some of the rocks which are. Do you understand this? Any doubts on this? This is based on the occurrence, based on the silica percentage. We have classified the plutonic, hyperbasal, and volcanic rocks, right? And index properties of rocks are, you have seen that color, grain size, so what you call this mineralogical compositions, and also you have seen that some of the rock called specific special properties, interactions, acid interactions, those things. Okay, let's go to the some of the rocks, physical properties of rocks, so that we can easily understand the things, right? So we have some of the rocks here. Yeah, here is the plutonic rocks. Okay, so generally the rocks, what do you call this, plutonic rocks, it's a granite. Just keep it in mind, it's a granite. So if you ask something for write down the physical properties of granite. So you start with this, the color. What is the color? Texture, grain size, mineralogical composition, essential minerals. What is the essential major minerals in the granite rock? And accessory minerals, it may be there, may not be there in the rock. Okay, and specific gravity. What is that specific gravity? So mode of formations, what is that? And occurrence, where it is occurring. Uses, what is the economic uses of this particular rock? And name of the rock. Name of the rock should be in the last. Based on these properties, you are justifying that, you are assessing that, okay, this is a pink granite, or it may be a gray granite, or it may be conglomerate like this. Okay, those things, right? So here is the plutonic rocks. So now so don't get confusion, plutonic, what you call this hyperbasal and volcanic rocks, right? So in the plutonic rocks or deeper level of forming, okay, it is a pink with a black color, maybe varieties of color of the granite, right? And the texture will be the equigranulars. So I will show you some of the images so that easily you can understand what is what. Otherwise, you will get a confusions. Yeah. Yes. Let's go to the the rocks called igneous rocks, granite. Yes. Can you see the rocks now? The specimens.
Yes, sir.
Yeah. So here, these are all the volcanic rocks. Volcanic rocks. And this is, plutonic rocks. Okay. And here is the hyperbasal rock. Hyperbasal rocks are very shallow depth. Okay. And these are all above the earth. And this is a deeper level of formations. Right. So here, okay, uh, what we are discussing that. Let me put into that any one of the slides so that you can easily. Oh, it's not in the slides. Okay. So here, when you see the properties a pink granite, color may be the varying there, the pink granite, or it may be a gray granite. So when it comes to the gray granite here, gray granite, what is that? If it is a pink color, you can write it as a pink color. So what is a gray granite? The color is gray with a block. Texture is equigranular. Equigranular in the sense, so grains are equally distributed here. You can see this, the grains in the mineral, it's equigranular. Here you can see this, some are of bigger size, some are of fine grain. So, but here you can see this in this rock, the grain sizes are very, equigranular, equally distributed, in the specimens. That's called the equigranular. That is called your textures, right? So here is the grain size is fine grain. Here you can see this, very fine grain. When it comes to the rocks, yes, generally it will be in an igneous rock. The grain sizes will be a fine grain, okay, not coarse grain, because of this is formed in the deeper levels. Okay, next point is that texture you got it, equigranular, grain sizes you got it, and mineralogical composition. Quartz, plagioclase, and quartz and plagioclase feldspars. So how we are going to identify whether it is a quartz or plagioclase and some extent mica. Here you can see this, the white what you can see in the rock, that's called completely quartz. So in the mineralogy, so in the first model you have seen the rock, so the minerals, especially in the quartz group of minerals. So you have, and you have seen the what the varieties of quartz, maybe the smoky quartz, or it may be in the milky quartz, rock crystals. Yes, in the, all quartz are almost all except smoky quartz. Yes, in the white color, that is called. Most of the rock, in most of the rocks, even if you take the sedimentary, igneous, and metamorphic, in all three types of rocks, there will be a quartz. There will be a quartz. Okay, so here major part you can see the quartz in the igneous rocks. Okay, and the plagioclase feldspar, it's very difficult to identify in this type of the specimens. Okay, when you come back to the college and when you visit the lab, then you can see then with the hand specimens with the magnifying lens, because it's a very fine grain, it's difficult to identify in the photographs. Okay, so that is the thing. So the black color indicates then the mica, the biotite and muscovite mica, as we discussed, the especially the biotite mica, black color, which you can see it here, the black one, the black patches completely the biotite micas. So right, so this is a physical properties of the gray color quartz. Okay, mineralogical composition, quartz plus plagioclase feldspars, and accessory minerals. See here, mica and hornblende. It's very difficult to identify there. Okay, the black color mica you can easily identify, and specific gravity will be the medium, and mode of formation, that is a plutonic rocks. right? I told you that that's a plutonic rocks. That's a deeper level of formations. And occurrence, it occurs as a batholith, like in the sense, you have seen the, the rock, the granite, it's a huge, like, Nandi Hills, okay? And in Bet also there is, the big hill. So it's a huge, olive wise, the big, in volume as you can see this, that we call it as a batholiths. And uses, what is the economic uses of this granite? The first thing is we use it as in building stones and also floorings. And also we use this for your, railway blast. What do you mean by railway blast? So when they are, making the, new track, or maybe, doing the alteration, and wherever you go in the travel in the train, so you can see the, that's, below the train track, there will be the rocks are spreading. Those are all igneous rocks. Just keep it in mind. Why we are using the igneous rocks there? As there may be a basalt, there may be a granite, there may be a syenite, there may be a dolerite dike, any. But all those rocks are igneous rocks. Maybe a different color, maybe a different, plutonic rocks may be there, or maybe the what you call plutonic igneous rock, hyperbasal igneous rock, all may be volcanic rocks. But those rocks are igneous rocks because it's having the high strength, because of that is due to the what you call the silica percentage in that. Okay, so that's why we use it in railway blast where the railway track is possible. And also uh, it is the character of, when they are, making the, like, different aggregates, like, what you call this gray granite. Generally we use it for aggregates, manufacturing of aggregates, different aggregates for a construction, concretes, okay? And also we use it for a building stones, especially for the floorings. So especially in the, what you call in the railway track, why we are using this, it will absorb the water, because that, the sizes, how they are manufacturing, based on the requirement, or especially railway track, they use specific sizes, so that when the rain gets the rain, it will absorb the water, and also it will absorb the vibration when the train is moving. So there will be a lot of vibration will be there. Okay, that will also be absorbed from those, the things. And also it will avoid to grow the what you call this uh, the grasses, the grass, especially the, grasses and some plants in the track. It will avoid that one thing. And it will absorb the water, and it will absorb the, vibrations, right? And it will, it's having the high strength due to high silica percentage in the granite. That's why we use it in railway blast. And also we use as used as a granite aggregates, different aggregates. And also nowadays, since 10 years, we are using the, the M sand, right? These are the, economic uses of. And also this granite, it's hosting many valuable minerals, many valuable minerals. That is maybe the, gold, or it may be, tantalum, tin, niobium, okay? And also even that's called, copper lead, this thing. It contains the valuable minerals, it, hosting the valuable minerals in the earth. Okay, that's why it is, even if you see the, the mica, you can see this mica in the granite rock, because it's a high heat resistance, right? So there are many minerals which are associated with the granite. That's why it's economically very important, especially the granite. Okay, it hosts the valuable minerals and also useful for building stones for different purpose. Right. This is a, gray granite. Like that, pink granite and gray granite, there is no much difference, but there will be a color variations because of different mineral it contains there. So here in the pink granite, there is no mica and hornblende, but in only in gray granite, mica and hornblende is there, and rest of the properties are almost same here, right? Okay, these are the the granite parts. Okay, right. Mm, let's go to the hyperbasal rock. Those are the plutonic rocks, and the other rocks are hyperbasal rocks. What are those hyperbasal rocks? So here, granite porphyry, granite porphyry. Granite porphyry is the hypervessel rocks. So here is that the rocks. See, hypervessel rock. Porphyry in the sense you can see the porphyritic textures, floor textures. See, this is a pink granite, it's a gray granite, and it's almost a little bit black granite. Okay, these three types of granite in the varieties, and there are a number of varieties are there in the field. Okay, so and this one is hypervessel. See, when you see the the pink granite, it is having the equigranular, and the grain size will be the texture will be the equigranular. But here when it is a porphyritic textures, and there will be okay, let me show you this. You can see the floor textures here, but here you cannot see this. Okay, this we call it as a porphyritic textures. Okay, that is you can see in the especially hypervessel rock. Okay, that's a granite porphyry. Okay, pink granite porphyry you can call it as. So here is the properties are like this. Maybe a pink color, maybe a white color, or it may be a red color. Okay, color is not a problem. So then next is the texture, porphyritic textures, PORPHYRITIC, porphyritic textures. Okay, that is a typical textures, the grain size textures, floor textures, you can see that. And grain sizes will be the coarse grain in this particular place. Okay, it is near to the surface, that's why it is a coarse grain. If it is a deeper level, high heat and high pressure, it will be generally the fine grain. So here is the hypervessel, that is a very shallow depth, just below the earth surface. Okay, that's a coarse grain. So mineralogical composition, orthoclase, feldspar, and quartz. You can see the quartz in almost all the rocks. You can see the quartz. Okay, orthoclase, feldspar, and quartz. So orthoclase feldspar means we studied in the last model in feldspar group of minerals. There are three minerals out there in feldspar group of minerals. So that you can easily connect those the rocks, the minerals, so that you can easily no, this not this one. Yeah. See here, these are all the feldspar group of minerals: orthoclase, plesioclase, and microcline. These are the rocks which you use it for manufacturing of sanitary wares and what you call this, and also the manufacturing of ceramic products and tiles. Okay, and these minerals are associated with the here in this rock, right? So that's called orthoclase feldspar, maybe a microcline feldspar, or it may be a plesioclase feldspar. Okay, that is the thing. And quartz is the weight one, right? And remaining some more maybe the high, some more maybe the medium, the special gravity. The mode of formation will be the hypervessel rock, and it occurs as a batholith, same just like granite. Okay, and uses as a building stones. Okay, and floorings, and and this is called a granite porphyries. There is not much difference in the granite and granite porphyry. It is having the porphyritic textures, that is having the equigranular textures, right? That is a this one. And another one that's called a diorite, or dunite, or a gabbros. Okay, right. Yes, here is the next one is the pegmatite. This is in the hypervessel rock. Now let's go back to the properties. Yes, granite, gabbro, gray granite we discussed that. Okay, and we want the pegmatite. Yes, yeah, gabbro. This is also igneous rocks. Okay, black on the block with the white patches and equigranular, and grain size will be the fine grain, and plesioclase feldspar you can see, magnetite and chromite you can see in the minor mineral. If it may be there, it may not be there, it depends. Okay, and specific gravity is a medium, and plutonic rocks, it occurs in the plutonic rocks. Okay, and batholiths, huge type of. Okay, it looks like a granite only, but gabbro, it is occurs as an intrusive, As I told you that intrusions, how it looks, just like, in the big moss, there will be a small, looks like a different rock intruding into the different way. That I will show you in the one of the picture, okay? So building stone, use it as a building stones for this. So Danite is also same there. And diorite, here it is, looks like a dike, these two are dike. And here in this maybe a gray color with a pink equilateral fine grain sizes, and it's having the feldspars and olivine. You can see the olivine, hornblende, biotite, all these three minerals are there in the diorite, okay, in the diorite rock. Okay, all these are igneous rocks. Don't get confused. All are igneous rocks. Some are maybe a hyperbasal, some are maybe a plutonic, some are maybe a volcanic. That's all. That is the classifications. So, but all are igneous rocks. Okay, and these three minerals are associated with the diorite because it's a plutonic rocks and it's a dike. And generally we use it as a building stones. Okay, and yes, pegmatite, and this is a very interesting one. I'll show you that where it is, how it is showing the pegmatite and all those things. So here is cyanide porphyry, and it's the same property, orange or pegmatite or porphyritic. So textures will be a little bit different because depends on the grain size, depends on the occurrence. The texture will be the different. Pegmatite textures, okay, and porphyric textures. So this here I have shown this. This is a porphyric textures. This is a pegmatite textures like a sugar, okay. And when it comes to the plutonic one, this completely what we call this equilateral textures, right? So here is the things. Okay, this is a pegmatite, light orange color, coarse grain sizes will be the coarse, and orthoclase feldspars, quartz. Orthoclase feldspar is a major, and quartz is a minor mineral, and specific gravity is a high. That is due to the heavy minerals which is hosting there, and mode of formation hyperbasal rock, and it occurs as a sill, and the dike. I will show you some of the examples. So how it looks in the field, okay, it's called a pegmatite, right? All right, then yeah, it's a granite and granite we discussed there, gabbros. Yes, these are all the igneous rocks generally we discussed there. So let me show you some of the what you call this, yeah, the volcanic rocks also. I'm going to show you there. The volcanic rocks I'm going to show you there, okay. Right, these are the the igneous rocks, and okay, let's go to the volcanic rocks a little bit there. We'll be touch with the volcanic rocks. Yes, that's a volcanic rocks. Okay, before that we'll go to the volcanic basalt. The completely basalt, you can see that, but you can see the properties of basalt. Porphyry, sandstones, gabbro, limonite, hematite. Let me segregate this so that that's missing. That is a quartz. Oh, those are quartz. I think somewhere is missing. Yeah. I'll show in the next class that properties. That's called a basalt one. Okay. Right. No. Okay. So here there's much of the properties in the volcanics. These are the volcanic rocks, okay? And here is the volcanic. There are, three types here in the volcanics. The one is called vesicular basalt. These are all the basalt. These are all the basalt, these three. Four plus this one, four of basalt. But here is the varieties. One is vesicular. You can see the vesicles here. In this specimens, you can see the vesicles. That's why we call it as a vesicular basalt. Another one is called massive basalt. There is no holes on this particularly, and it's a massive basalt, a very fine grain. And next one is the uh, uh, amygdalar basalts. So here you can see this. These structures we call it as amygdalar basalts. Okay. Then this is also the massive basalt, vesicular basalt, massive basalt, and amygdalar basalts. There are three types out there. Okay, and these so vesicular basalts, which are formed during the eruption of lavas, along with the lava, so generally lava contains the volatile materials, rocks, minerals, gases. Okay, those gases when they are erupting, so these the holes are formed there due to the gases formations. So after some time, later stage, so these the voids or maybe the holes got into filled with occupied with some other minerals. That's called a secondary minerals. Here you can see this. It may be a quartz, it may be the zeolite, or it may be any other minerals. It come and occupy in the particular place. So here is also same thing here. Okay, this is we call it as an amygdala textures. So color is maybe the varieties of colors in the granite, sorry, in the basalt. It's maybe the green color somewhere, and it's black, grayish black, and here is also the little bit greenish, the gray color, and the fine grain sizes will be the fine grain sizes, and the textures. So these are the properties which we are following, same properties which you are following, but what you call this? Yeah, this is same things we need to follow. What is the color, texture, grain size, some fine grain sizes, and texture may be the vesicular textures. That is because of vesicles in the specimens, vesicles in the rock. That's called a vesicular basalt. Okay, and when it comes to the mineral assemblages, it may be a quartz, and there will be the mica, there will be the magnetite, there will be the hematite minerals will be there, and mode of formation is the it's in the in the volcanic rocks. Okay, it occurs in almost occurs as a boulders or batholiths. So here it is. So see, gravity will be the high always. Okay, and generally we use this basalt for building stones as well as for railway blast and all those things, right? And name of the minerals you can write that. So here is a typical property of this rock is vesicles and amygdalar basalt. So next one is called a pumice. I told you that is a pumice. This is a white one. Here it is also the equilateral, and the textures will be the uh, vesicular textures. Means vesicles, you can see the holes there, vesicles. That's we call it as a vesicular textures. And next part is that this occurs generally in the volcanic neck that we have shown in here. When the volcanic eruption is happening, in most of the time, you can see when the volcanic eruption happening, that is in Malaysia, where there is islands, there is a chances of the most of the time, especially the Malaysia and even in island areas, the volcanic eruption is happening there in a continuous process, right? So the pumice you can see in the volcanic neck in the bay. Okay, and yeah, this is very lightweight. Okay, when it comes to the the galena minerals, so galena, if it is less than this volume size, the weight will be the more. But when it comes to the pumice, so the volume wise size is more here, but the the weight wise is very less. So that's why we use this for lightweight concrete, use it as a lightweight concrete in this particular place. This is called a pumice, white one. Okay, so these are all the the volcanic rocks which we studied there, and sorry, so almost all the igneous rocks: plutonic, hyperbasal, and volcanic. There are three types of rocks in igneous rocks. These are all igneous rocks. We may ask, write down the physical properties of the granite, or a gray granite, or maybe a pink granite, with a detail of chemical composition and also the economic uses. These properties you need to write down the things like what we have shown here. Like this, you have to write. If you ask them, 2-3 minerals like this here, you need to write down one standard the properties of rocks, and next 3 minerals you can write down the column. You can write it this way. That would be the better for us to evaluation. Okay, so properties should be the clear cut, right? So if there is the sediment rocks, or if you ask the sediment rocks and what do you call this igneous rocks separately, generally we used to ask, but you need to write down the properties very different way, because igneous rocks properties little bit varying than the sedimentary rocks. Okay, uh, right. So there may be sediment rocks. There will be cementing materials will be there. Okay, and there will be grain sizes, and there will be some more typical properties will be there. Okay, almost all same like igneous rocks, but 3-4 properties will be the change. These properties. Okay, and these are all the the igneous rocks generally. We you have seen most of the rocks we have seen, but you might not identify. Yes, this is this rock. This is this minerals. Generally, you have seen that most of these are used as a raw material for construction of your projects, civil engineering constructions. And this one is the granites completely used for the slabs, as well as for floorings, as well as for the aggregates. Okay, and also for the railway blast. This completely, and this one generally use it for building stones, and especially the pegmatite. This hosts the very valuable minerals that's called tantalum and niobium. Tantalum, niobium, and also the tin. Tin is generally we use it for the manufacturing of guns, and also for the tin coated the products. Okay, and also it hosts some valuable minerals which is very rarely occur in the world, especially in India. We have not much this the tantalum and niobium mines, but in Africa and rest of the world, okay, except in India. So there is a very limited place you can see this tantalum and niobium. Here you can see this black spots. This called as tantalum or niobium. These two minerals we call it as in general term called as coltan. So this is actually the value of 1 kilo of this in the world market. 1 kilo of this the coltan that contains niobium and tantalum. If you check your what you call this periodic table in a chemistry periodic table, where the tantalum and niobium minerals, okay, the elements, and if you check with the internet, what the value of that. So that is a very occurrence is very limited. Okay, that's why the price will be the very high. This 1 kilo of the tantalum niobium that we call the coltan, that is a 30,000 to 35,000 1 kilo. So when you see the the mineral called hematite, that's called iron ore. So 1 ton of iron ore price will be the 3,000, maximum 5,000. Export price may be the 8,000. Export of the iron ore from India to some other countries, that may be the 7,000. Depends on the market demand and supply of that. Based on that, the commodity price will be increases. Definitely, it will be every day. It's a varying, but especially this the tantalum niobium, it's a very occurrence will be the very limited place and limited countries, and the extraction will be a very difficult part, because it little bit feebly the radioactive minerals. These two are. So that's why it's very, scary to, mine it. That's why the price is very high, especially for this. So just to compare, hematite ore is available everywhere in the world. So it's in the bulk commodity. But the tantalum niobium, it occurs in the very limited and a very narrow, what's called a vein type of deposits. So mining is very difficult, occurrence is very limited. So that's why the commodity, the mineral price is gone up. 1 kg of tantalum, 35,000. 1 kg, sorry, 1 ton of the iron ore, 3,000 to 4,000. That is, availability is more. Everywhere it is available, iron ore. That's why the prices will be very less. The availability is, available of the mineral, tantalum niobium is very less. The price has gone up. This price, the tantalum niobium, generally we use it for in our electronics, maybe a television, TV, or it may be almost all your gadgets like, mobile, handset, computer, laptop, everywhere, because it's a high heat resistance, which contains a high heat resistance. That's why we use it, this in almost all the electronics. Okay, whatever you are using, mobile, it may not be the high heat, because that's because of it uses, it's manufactured by using the raw material called tantalum and niobium. Let me show you some of the images of the tantalum niobium so that you can easily understand what's what that. Right, let's go tantalum. And this is how it looks, the tantalum mining. It's a very narrow, or what you call this, the mine will be the very, here you can see this. Say this is only the product we will get it. This is a pegmatite vein. Can you see there's a slide now, Chiranjeevi? Yeah, here is, this is only the what you call this pegmatite vein type deposits, we call it. And rest of the place, rest of the this clay minerals, it's a waste. This may be the schist, or it may be the phyllite. To extract this mineral, we have to remove the waste. That's why if you want to remove 1 ton of this, 1 ton of the pegmatite ore, and we have to remove the 10 tons of, or maybe the 20 tons of waste. That is your, the waste and ore ratios, and the budget will be the very high when you are going to mine it. That's why the commodity price, the mineral price will go up. Okay, that is how the things. See here, it's a vein type deposits. This may be a little bit thick, thinner one. It may be hardly maybe a 20 meter. From here to here, it's a 20 meter. And rest of the place, this is a waste. And here is a small patches here. It is crossing like this. This is a east generally, and this is the west, and here is the north for this. Okay, and this is how it looks like, that pegmatite mining. It's in Central Africa. Okay, Central Africa, right? So here it looks like, to show you some of them. Okay, the minerals. This I will show in the next class. There is a very good the images which I can show you that. I will take you to the in the mining sector, so that you can see the what are the minerals, how it looks like that. So let me take you in the raw material department. So how they are processing, how we are going to use what you call this the raw material for your the rest of the world. Okay, right. So almost all we are using the natural resources for manufacturing of electronics, or it may be manufacturing of iron and steels, cement and aggregates, and also for your what you call this manufacturing of glasses. For all the the commodities, the minerals we are using naturally, which are occurring on the earth, knowingly, unknowingly we are using, because you are a civil engineers, I'm a geologist, we know the things. So other common men, I'm not sure they are aware of this. Yes, where it is coming, how it is coming, how they are manufacturing, what is the raw material for this particular product. They are not at all bothering the things, because they don't want actually these things. So this is how the raw material for almost all the commodities. Okay, let us stop, and I can take a break, and then we'll continue in the next class. It's a very interesting one. I'll show you the best, the world best mining, especially for different commodities, and how best we are using this raw material for our constructions, and also for hosting the valuable minerals. Okay, let me start with the links there.